This is TWIS, episode number 805, recorded on Wednesday, December 30th, 2020. 2020 Science in Review. I'm Dr. Kiki, and tonight we will fill your head with memories, laughs, and science. But first, thanks to the Burroughs Welcome Fund and our Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. 2020. As we end the year, the planet has lost 1.8 million humans to a virus. Over 82 million have been infected, and we are at the peak of transmissions and deaths, just as a new variant threatens a more contagious acceleration of the infection. 2020, so contagious was this year that even as it leaves, it is passing along the virus to the following year because we failed to mitigate our behavior with any concerted effort. 2020, the year that showed how poorly wishful thinking, political posturing, and good old-fashioned ignore it, maybe it'll go away strategies fare when dealing with actual threats. And so when the future looks back upon this present, the real threat will be less about a virus acting out its nature, but the failure of humans to take reality seriously. 2020 was also the year that challenged science to save us from ourselves. Around the world, researchers went to work, searching for treatments, developing and testing vaccines, and the efforts have succeeded. It's extremely important to note, and I cannot stress this enough, I might even need further disclaimering, these solutions are not new, not fast, nor are they easy to arrive at. The vaccines are based on technology that has been developed over decades of dedication by scientists who encountered failure, suffered setbacks, lack of funding, and yet persisted in their work, pursued the scientific method where it led them, and while they persevered and have prevailed in creating a vaccine that is capable of saving 160 million more lives over the next few years, roughly the number that would die if we were trying that herd immunity nonsense globally. They prevailed because they were dedicated, and they had dedicated their lives to the pursuit of science. These studies that happened, they could have been on a fungi. They could have been on a bacteria. They could have taken place with a fruit fly or whatever the viable model might have been, and to the untrained mind might have seemed frivolous. But the end result of all that hard work and dedication and searching for answers is what led us to the potential vaccines that are going to save so many lives. So before we say so long, goodbye, good riddance to 2020, we pause for a moment to look back at some of the knowledge that dedicated scientists have brought to light in their efforts to take on the next challenge. On This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to our last episode for 2020, the year that we just can't wait to say goodbye to.
The year that lasted 5 minutes and 200 years at the exact same time.
That is so true. So true. Oh.
I have to say before we get started that I was so worried at the start of the pandemic that there would be kind of a stoppage or a drought of science this year. And it didn't happen. It really didn't happen.
It never happened. The science kept coming.
We talked about it, and it was a real possibility, a real threat. Like, what if everybody can't go to the lab? I think that's still coming, though, because I think what we're experiencing in the lack of science was all these researchers being able to drop a lot of other things and work on their papers.
That's true. Yeah.
Yeah. And so there may be some sort of hidden deficit of research that didn't get done, expeditions that didn't take place, field work that was canceled, things like this that are going to sort of trickle in over the next year or two or three. But I do think we got a plethora of science because so many researchers just, it's time to finish that paper that we were working on, and now we have all of the time.
Just keep publishing. A veritable cornucopia of science.
Can't go to the lab, publish your review.
Yeah,
exactly.
Great. It's still very valuable science. Yeah.
Mm-hmm. Yeah. So we thank the scientists for continuing to work and endeavor in science throughout this year so that we could keep doing this show because science is awesome. It's amazing. It gives us hope for the future. At least that's the way I think about it every single week. Okay, so this week, this show is our top 11 of 2020 countdown. Now, what does that mean, Justin?
Well, typical show will give you a top 10 of what has occurred in the past year, leaving you wondering, what was that 11th thing? What did they leave out? Was it just really not that important? Because there's a lot of things that happened. The 11th thing is still a really important thing. So we provide that 11th thing here on This Week in Science. You don't have to wonder.
But you can just wonder about the 12th instead.
Right? What were the other things?
And it didn't even occur to me.
And in fact, our list went to like 14, and we have honorable mentions and weird science that we have to mention at the end of the show too, but we're just counting down from 11. We're not necessarily going to tell you about 12, 13, 14. We're going to get to the weird stuff because that is always fun also.
And it's always important to remember too that, like, I sort of teased this in the disclaimer a little bit, but the research that led to the vaccine that's going to save hundreds of millions of people, when it first is getting published 8 years ago, some of the ability to use the messenger RNA in this way, it probably did so without much fanfare.
Right.
It may not have been on the show. It might not have seemed as crucial or as important as it is. So within all of the stories that we try to cover and all the ones that we miss, the many, many, many thousands of stories that we miss every year, there are stories out there that are going to dramatically impact the future of humanity. So all of it is important. We're just going to focus on some of the stuff that tickled us and we liked. I guess.
Yep. It tickled us throughout the year. And we hope it tickled your science bone as well. Are we all ready to jump in?
Let's do it.
Okay, fantastic. As we get in, I want to remind you that if you are not yet subscribed to This Week in Science, you can find us on YouTube, on Facebook, on Twitch as TWIS Science. And we are on just about every podcast directory that's out there. Look for This Week in Science. You can also find our website at TWIS, TWIS .org, not at org, twis.org. That's easy. Twis.org. Go there for show notes and stuff. We also have a very, very small number of calendars left if you really want to have something to look forward to in 2021. Make it Blair's Animal Corner art because there are a few calendars left. Not many. Just at the end of the stack right now. So get it while the getting's good and get your order in before the end of the year. You got what, like 24 hours? You can do that. Okay. We are starting the countdown at number 11.
Number 11. So I'm really glad that we went all the way to 11 this year because something that I think both Kiki and I noticed when we were going through this year's stories was that there was an amazing arc over the year, especially in the animal corner, relating to bioluminescence. So I think pretty late in the game in 2019, there was a story about squirrels fluorescing pink. And I think then just all year, scientists were taking black lights to specimens in museums and things like this.
Everything.
So we found out most amphibians fluoresce. We found out tardigrades fluoresce. We found out scorpions fluoresce, or we knew that they did, but we got a good idea of why and how. And crazy one, speaking of mammals fluorescing, we found out that platypuses fluoresce, just to add to the craziness that is platypuses. So lots of glowing animals out there, which begs the question, where's my ability to see fluorescent? Because Clearly, most animals, I guess, can see it.
Yeah, we can see that ultraviolet glow at the in the evening and in the morning when the sun is just right and the flowers start to have that more purpley color to them. But yeah,
Sure.
why? I mean, we years ago we found out, or 3, 4 years ago now, that people may emit a bit of light as
Ever
well,
so slightly. Yeah.
ever so
Yeah.
slightly. But so can we detect it? Why don't we detect all this bioluminescent fluorescence of these animals? It's not for us. They're not in
No.
our communication realm, right?
No, so I think there's with all of these stories too, there were two schools of thought. So one is that it's somehow related to communication and that it's intentional, and another is that it is a weird byproduct of the protein structure of these animals. And so with all these different stories, could be some of column A, some of column B, could be all one or all the other. We don't really know. So I think that's something to
Yeah.
look forward to in the future, trying to figure that out, finding a way like, can you block bioluminescence in gene expression? And then can you see if that impacts an animal and their behavior and the behavior of animals around them? That's something that we
Right.
could do to see if, do squirrels and platypuses really benefit? But
Yeah.
I mean, it turns out a lot of animals out there glow. So
You got that look. You got that glow. That's right. All the animals. I love the tardigrade because it isn't all tardigrades. It's one species of tardigrade that glows, which was kind of exciting. I remember that one. That was kind of neat. And it bioluminesces pink. Like it's a different color.
yeah, and
And
they
then
think that the fluorescence shields itself from lethal radiation.
right.
Which
Oh, interesting.
why? Because I think it's mostly radiation levels you'd get from being in space, which is part of my whole like tardigrades or aliens thing.
Right. Have they
I
taken over the surface of the moon? We
yeah.
will find
Who
out.
knows?
Yeah, and then what was with the platypus? That was another exciting one because we've been looking at the platypus like you're a weird animal just
Mhm.
anyway, and suddenly you're fluorescent and bioluminescent also, and that's
You're
good
a
for you.
venomous mammal. You lay eggs and you're a
Yep.
mammal. Let's throw in glowing on top of that. Also, you're so weird looking that people thought you were a practical joke when you were first brought back.
I don't know, not a practical joke, just
No.
ecologically practical.
Ah.
Gonna put it
Mhm.
out there.
Yeah.
I'm gonna put it out there. Do you have anything else to say about bioluminescence?
I mean, they would all fit in really well in my bedroom in middle school with my UV light and my lava lamp and my beaded curtain. I can tell you that. Pretty
Yep. Yeah, the glow in the dark animals, not just for scientists, for the
So,
kid in you as well.
so then the
Yeah.
thing that fascinates me too about this is bioluminescing is one piece of it. Can they see bioluminescence is another
Right.
part of it, because then, hey, we've got this weird thing. Now we can use it for communication to know where our friends are, or maybe they can't see it, but the predator can. And then that
Right.
predator happens to go after them because they can just find them over time, and that beats how they become their main predator. So there's like this whole amazing interconnection every time we find one of these weird things that animals are doing, that it attracts or protects them, attracts their predators or protects them from being predated upon. Tardigrades been around a while. Maybe they're just like, yeah, you mammals are doing okay, but Earth goes through some changes. You
Mhm.
got to be ready for everything. You don't know what it's going to throw at you next. So be ready.
Changes. I'm changing the topic to number 10.
Number 10.
Number
Number 10.
10.
Asteroid sampling.
Ooh.
Asteroid sampling is our number 10 topic for 2020. This year included the Bennu Boop, in which the little craft Bennu decided that it was going to take a bite out of asteroid Ryugu and send some stuff home. It's on its way home now, hopefully to arrive at Earth in 2023, which is a
Mm.
few years away before we get to see what comes of it. That said, Hayabusa 2 also landed, well, not landed, Hayabusa 2, amazingly, put some rovers on its asteroid, and then went down, sampled a little bit of that regolith, brought it back, and then shot a canister at Earth. Hayabusa 2 is still traveling in space. It's off to see other asteroids. Its job is not done yet. Hayabusa 2 is still going, but it shot a little canister back to Earth. It landed in Australia, and Japanese scientists at JAXA have gotten their sample. They've opened the canister. It was not tarnished by Earth's atmosphere, and they're starting to look at stuff to see what is on the surface. NASA is going to get about 10% of the regolith from Hayabusa 2's sampling mission in trade for a little bit of regolith from the Bennu mission. Little asteroid sampling tit for tat going on there between global scientific organizations, space organizations, which is very cool. I love international collaboration. But this year, it's amazing. I mean, we had 2005 was the last time that an asteroid was sampled. Hayabusa 1. That was a crash and burn.
The plucky probe that could.
It was a plucky probe. It crashed and burned. The sample was contaminated, but they got some stuff out of it. It was okay. But Hayabusa 2 knocked it out of the park, and now we've got the Bennu mission coming up behind, and we are learning more about our solar system, about how our solar system formed. What are these objects that are out there orbiting?
And we learned a tremendous amount about that from meteorites that had landed this year. We took a meteorite that landed, I think it was in the 70s, and was in a collection somewhere. And upon closer evaluation with some new techniques, that and I think 17 other meteorite fragments that have been collected over the years, we discovered that asteroid formation takes place differently than we had estimated it to take place. As well as we had discovered in fragments of meteorites, dust particles that were older than our solar system.
Yeah,
That's
exactly.
Pretty cool.
It was very cool.
We've got dust from before the solar system even formed, collecting in meteorite and asteroids, and then meteorites, and then landing on Earth, and then getting analyzed by scientists here.
Going to tell us the story of our solar system and our universe. But this leads us in to, I believe, our next topic. Number 9.
Ooh, number 9.
Number 9. Number 9.
Astrophysics. Yeah.
Astrophysics.
There was some pretty cool stuff discovered through the telescopes and what have you this past year.
Yep.
Keck looked at a speck, and that speck turned out to be the furthest away and perhaps therefore oldest galaxy ever spotted in the known universe. 13.5 billion-ish.
It's like
light years away. How do you even say this? It was 13.5 billion years old, but that's also how many light years distance away it is.
Yes.
At the same time, because we're looking at the so that's also, this is pushing that edge of how old the universe is. This is a fully formed galaxy that is right there at the beginning, or close to what we thought was the beginning. So maybe the beginning's a little bit before that, but it's really close to when. And we found also a solar system that was sort of Milky Way-ish. That was also very, very ancient.
About 12 billion years old, right? It was just a little younger, but still the same kind of idea. Like, oh, this is like the Milky Way, this nice formed spiral galaxy. But it's so old, it shouldn't have been there.
And one of the things too is, and I don't know how the time scales of these things work still, but we have a quasar, or a black hole at the center of our galaxy that keeps things spinning around. And I think we're on the smaller side of galaxies, really, anyway. But that means black hole formation, which you could think of as just taking in all this aggregate matter over time very slowly. Although in a denser early universe, maybe these things happen quicker. But yeah. And then we also had the geodes, perhaps these things being responsible for the dark energy.
That was a fun interview.
That
was
a
really
great interview.
interesting. Yeah.
We have, and then the Mond is looking at gravity out there and got a confirmation on the Mond theory, which, we've talked about Mond as this sort of modified Newtonian gravity thing for how gravity works. And it's not been the most popularized version of it. I guess people have been skeptical, and they made a prediction a while back. An observation has been made that confirms that prediction. And then now you have to say, ooh.
More testing.
More. Well, you might see more, but now,
testing.
When you make the prediction, when you make...
Oh, go ahead.
Oh, just when you have a theory on paper, this is how we found the Higgs. This is how many of the things that Einstein discovered started on paper, started in an equation, said, hey, based on doing the math, I think, right, there should be this phenomenon that can be observed somewhere in the physical, actual universe. When you make the observation and you find that signal, whether it's a Higgs boson or a gravity wave or whatever you're talking about, it leads great credence to the rest of that work, or at least it lets you know that it's on the right path and can find actual solutions for reality. Very, very.
Yeah. What about the fast radio bursts also? That was a big one for this year. At the beginning of the year, like for years, it's been like, what are these fast radio bursts? We don't know what they are. Right?
It wasn't alien intelligence.
It's not aliens.
No.
I can't remember. Was it a magnetar? What was it?
It's a magnetar. Yeah. So it was last, I think, January, early February, there was a report of localization of where a fast radio burst was coming from that was very predictable. And it was like, okay, we got that. And then observations were made. And then in the summer, there was the Northern Hemisphere summer, there was an observation of a magnetar, Death Star magnetar, as you called it, Justin. And it was weird. And it took until November of this year. But at the end of November, it was announced that they had identified that this magnetar from a galaxy had exploded with radio energy, and this magnetar had sent out this fast radio burst, which we detected. So they were able to correlate the light and the radio signals at the same time to be able to determine that, oh my gosh, magnetars, at this point in time, this is the one thing that we know. We've seen it happen. It was predicted. Like you were talking about, predictions and then observations. You have to go out and do it. They predicted magnetars might be one of those things. They saw it happen. They made that correlation between the light and the radio and energy, and magnetars, the source of fast radio bursts. And I'm sorry, it's not aliens, as far as we know.
Not tardigrades on some comets sending out little fast.
But the good news is that just means we're still the top alien in the universe, as far as we know.
In our neighborhood?
In our neighborhood,
that's
right.
As far as we know.
Number one.
And yes, the chat room is pointing out Arecibo was lost this year.
I didn't want to talk about that because it's sad. But it is a very stark reminder to the international community how important it is to maintain our equipment that looks at the universe. If we let that equipment go unmaintained, unretrofitted, without bringing it up to new standards, things are going to get old. We're going to miss things. We aren't going to be able to do the science that we want to do. And I think that's really, I think of everything, the loss of Arecibo is it's terrible, but I do hope that it leads to more investment in astronomical equipment for us to look at the universe. So we can find our life cousins. Who are the other aliens? Who are the aliens in our neighborhood? In our neighborhood.
I like Shnogo in the chat room is saying that magnetars aren't real, so the aliens are just making it look like it's magnetars. But
Could be. I
Yeah.
mean, I don't know who makes the magnetars go boom. I didn't make it happen. Oh my goodness. For a quick moment here, I just want to remind everyone, this is This Week in Science. Thank you for watching. Thank you for listening. We are in our 2020 review show, counting down our top 11. If you don't have a calendar yet, they are still available for a very short time. We have a limited quantity remaining. Go to TWIS.org to get your calendar today for 2021 with Blair's art. It's amazing. Okay, moving on. Moving on up to number. Who's in charge of this one?
Number 8.
Oh, I'm sorry, I didn't see you from around this calendar that's still available. Anyway.
Nicely done.
Number 8 is all about animal cognition. As I feel like this is one, there's certain things that show up on the countdown pretty consistently from year to year, and this is definitely one that shows up. It's not the first time. It's all about animals are smarter than we thought. Shock and horror. For example, we learned that wasps can actually tell faces apart.
That's terrifying.
Yeah. We also found that bees, they actually they somehow become more efficient the more nectar they're carrying. So, and it also appears that they actually can decide whether to be better at flying or not in a specific moment based on how much they're. Anyway, they're a lot more self-aware. Yeah.
The bumbling bumblebee is not so bumbling.
Mm-hmm.
It can bumble or it can fly efficiently.
And it's not even on our list, but that reminded me also really recently, there was a story where there were bumblebees that were figuring out how to orient themselves differently to be able to fit through different shaped holes. So they're very self-aware of their own shape in relation to their environment. New Zealand songbirds were able to remember food-related memory tasks for up to 2 years. Also not on this list, but also off of the top of my head, finches can remember other finches' chirps for 42 different individuals they can keep in their head and recognize the voices of 42 different finches.
I think my favorite one was the mice being able to smell cooperative nature of another mouse.
The rats. It was rats.
The rats.
Yes.
Yeah. The rat that could smell if another rat was in a cooperative behavior mode.
You smell like a cooperator. I'm gonna hang out with you. You're cool.
Yeah, not even are you nice or not, but like, what kind of mood are you in?
It was like specific because that same rat could be in a different mood, and it's like, oh, forget you. Mm-hmm. But they could smell if they were like in a good mood, in a helpful mood.
Yep, and speaking of kind of a similar smell taste vein, worms can tell their babies what food is good and what food is not good through their DNA. So a specific RNA sequence in bacteria tells worms not to eat them, and then children and grandchildren of those worms are born knowing to avoid that specific RNA sequence. Crazy. Hummingbirds.
I mean, it's like cognition plus a genetic understanding. It's like I'm hungry, and this is instinct, but also how I go about searching for my food.
Also, hummingbirds can count, I guess. Crazy. And crows have consciousness, despite lacking a cerebral cortex. So, bottom line, as always, animals are smarter than we thought. They're more self-aware than we thought. And humans aren't special.
Humans aren't special. And in fact, looking at these animals, or animals also, by the way, looking at these animals who have smaller brains than we have, who have these abilities. Crows with consciousness. Hummingbirds able to count or have numeracy, the number awareness. Like, come on, everybody. What are we doing with this giant mass of neurons if tinier masses of neurons work just as well? Come on.
Little invertebrates just have like a lump of nerves. They don't even really have an organized brain, just like a glob.
Yeah, Blitzbot's in the chat. I could never get over the fascination and shock scientists have when living creatures display having intelligence. It's not. I kind of almost disagree with that statement a little bit. I think it's more the general public to a degree that has that. It's usually the scientists in the field who are observing animals, who are life scientists or nature scientists who are observing animals in the field, who are seeing firsthand cognitive behavior, a sort of theory of mind behavior, of knowing friend and foe and other, and watching these interactions, who then publish these papers showing, but they have to not just say, here's what I saw, because seeing something isn't scientific evidence. They
That's
have
not
to
science.
go and create
Right.
an experiment that attempts to recreate what they're observing in nature so that it can be published under the scientific method. Because people seeing stuff and reporting on it is like the worst way to know anything.
And I think this gets at, one of the issues in between what we see anecdotally as people observing animals versus scientists working with animals is that we have to be able to test a question. And if you can't figure out how to test a question properly, like how do you test for consciousness in an animal that cannot talk about it? How do you test for the ability to count in an animal who can't count to you? So these are really, you have to think like the animal. You have to figure out how to make tests that the animals are going to want to do. You have to figure out the intelligence quotient of an animal, you have to make it context appropriate, the same way that you would do it for a human. So the way that scientists look at things is that in order to be unbiased and to create something that actually is evidence, that even though they might go, yes, birds are smart. Yes, crocodiles are ridiculous. You still have to test
what
it
is it called?
appropriately.
Pack hunting alligators? Wasn't that
Yeah,
I don't
that
even
was
know if
quite
that
a few years
was
ago. Yeah.
But,
No, that was like 5 years ago.
that
But
was a while ago.
but I think, the other piece of this, and this is something that Kiki can directly speak to, is I'm sure she knew going into studying zebra finches that birds are smart and that finches are smart. But it's also about studying the brain, right?
Yeah.
So this whole thing about crows not having a cerebral cortex but having consciousness, the question isn't necessarily whether crows have consciousness. We probably anecdotally have a good idea of that, but it's a question of mechanically what's going on in a brain from species to species.
Yeah.
Is there something that makes our brain different from other brains? Because our brain is not just talking about humans, being superior or anything like that, because obviously I don't fully believe that, but talking about just objectively what a human brain looks like, it looks very different from a lot of the animal kingdom. And so that's really what I think a lot of these studies are trying to get to, kind of in the underneath, is trying to figure out what is there something that makes our consciousness different from other animals, considering there is a pretty big structural difference in the way our brains work.
There's a pretty big intelligence gap too.
Structure defines function.
There's a pretty big intelligence, or at least cognitive ability gap too. I mean, an animal doctor is a human that will treat an animal, not the other way around, ever.
Thank you for the animal cognition, Blair. We're going to move to the next number.
Number 7?
Number 7. Oh, it's me. Oh, yeah. This is the metal organic frameworks. Metal organic frameworks have been showing up more and more. This is tiny ionized metal particles with some organic material. They're getting shaped into doing. They're being used now as a potential next semiconductor. They're being utilized as drug delivery. They're being talked about in new forms of batteries. One of the stories that we covered, they managed to collect a bit of energy in there and release it months later. Something sort of unprecedented for a solar cell itself to hold heat and release it months later without loss. So this is just the beginning of this tiny, what's also been described sort of as Lego block technology. They've managed to get these things to self-organize because they are designed and engineered such that they will only connect to each other in a certain way. It's not quite the those nanomaterials self-replicating robots that we've been talking about some years back.
And that's kind of good. I mean, I don't need nano self-replicating robot gray goo taking over the world, but let's get some useful stuff here.
But being able to throw all of your Lego blocks into a flask and stir it around with a catalyst, and then have your Millennium Falcon already made with its 2,000 pieces, that's not a bad deal.
It's not a bad deal at all. I mean, I really love the story though that you brought up of the battery, where it's not just a battery, it's able to take energy from the sun, so photosynthesis type solar energy, store it for months. Like, not like I'm just going to take it in for a second and be a capacitor and then have to give it out, but months later. So they're talking about being able to use it, be able to collect energy during the summer months and to use it in the winter months. So someplace like Antarctica or Greenland or, northern countries that have really diminished solar energy during the winter months, this might help to supplement some of that. It could be used to help us wean ourselves off of carbon, off of the gases. I mean, if we can get it's batteries and storage devices that are the biggest stumbling block for us being able to uptake globally sustainable and alternative forms of energy.
So the acronym is MOFs, or the abbreviation is MOFs, MOF. That I think it's like, this is like this is the first year we're really starting to talk about this technology. It's going to be the next
around though.
It's been around, but it's going to be the next thing. Like CRISPR was sort of a thing and it was around, but then it became put into functions and it became the thing that was in every third story for a while and continues to be. But there's so many of them that it's not as exciting just because it's CRISPR anymore, even though that's like a lot of pretty much all of biotechnology is running off of some sort of CRISPR type editing technology. But MOFS is going to be that next big thing. The next big thing for that we're going to be talking about, I think, for some years to come.
I think you're right. I remember we've talked with other researchers about not just MOFs, but other these framework molecules, organic frameworks,
programmable proteins type things.
Yeah, and other ways that one of the other aspects of these MOFs that's really cool, and not just MOFs, but organic frameworks, is that they have empty space. So the spaces between the atoms can be used for storage. So you can stick other stuff in there. And that's one of the coolest parts. It's like, okay, so maybe we can use it like a sponge. Maybe we can use some of these things for environmental cleanup, for cleaning up oil spills, or, who knows?
And the other is it's a sponge that can have a mechanism of release of the sponge. So if you sort of picture sponging something up and then it's locked in there like a brick. And then you can put it where you want and you hit the switch and you can release everything that was in the sponge. That's why it has potentials for drug delivery. That's and absolutely environmental cleanup or wastewater treatment, all of these things that have been increasingly important issues that we've had to come up against. So there might be options there as well.
And for our chat room over off our website, TWIS.org, Dick Tell, who's been in the chat room many times, he works not so much with these metal organic frameworks, but he works with organic frameworks generally and has done some really interesting work on it. So if he shows up in the chat, say, hey, tell me about those frameworks. Pick his brain a little bit. Are we ready to move to another number?
It's time for number 6.
I feel like I'm getting older, but I don't have to anymore.
Yes, please.
Yes, please. Number 6 is aging, because there was some amazing research this year related to basically reversing problems of aging, reversing Alzheimer's, nuclear reprogramming, erasing aging in old cells. What was another one? Resetting the epigenome in human eye, not in human eyes, but in mouse eyes. All this stuff, of course, it's in mice so far. We're doing a great job of resetting the clock for mice, but maybe one day it will lead to us, which that's the next big question. Can we reset the epigenome in our eyes and allow aging eyes to see better, to get rid of problems of like glaucoma or macular degeneration? Could we reprogram the nucleus of our cells so that the nucleus doesn't think it's so old anymore and doesn't have those epigenetic marks that come after a lifetime? And the cells themselves, instead of acting like old cells, might start acting like younger cells. We saw that they were able to reverse Alzheimer's. A drug candidate that was developed by Salk researchers was shown to slow aging in brain cells and actually clean things up in the brain so that cognitive decline was reversed in mice. Really some groundbreaking research. And I don't say groundbreaking lightly because it is such a sensationalist word. And UCSF had a drug that within days reset mental decline in older mice. Within days. And it was, you can take this
That's a
for a
really
while.
important one. That's the really important one. Sexiness in the chat room says wrinkling? Question mark. So here's the thing. Who
We
cares?
don't have anything for wrinkling left.
No,
Just sleep
no.
so that you can be good to your cellulose.
Here's the thing. If we all live to 250 years old at some point, but we still start getting those wrinkles, when we do now, wrinkly will be the new sexy. It will be the norm. And you'll have young people going to get wrinkle cream.
I don't care. Wrinkles
You'll
be
be wrinklier.
I don't care at all.
No, there was
some wrinkle cream.
You say that, Justin, but there was a study on circadian rhythms and how they affect the degradation of cellulose in our skin, and so maintaining your circadian rhythms. So sleep. People always talk about sleep being so important. Maintaining those circadian rhythms actually helps to maintain your cellulose. But
there was a story this year also about what causes gray hair, which we didn't really fully understand until
like
this year.
Stress and sleep, and there was
but it's I think like they found out chemically what's happening in your body from those experiences that cause gray hair, which we didn't know before. So I guess also that could kind of fit into this category.
We will get there. We will. I mean, I see the day coming, not 5 to 10 years, much further down the road, where people live longer, better. It's going to happen. But how are we going to live longer, Blair? There was the story related to families. They were looking at a Dutch family and their telomeres and cancer prevalence, and they discovered that the shorter telomeres are better.
Yeah, that was really, I feel like that had to be mentioned because we've been talking about, I want longer telomeres. Like, give me those aglets, those shoelace covers that everyone needs in order to live longer. Like, why you die of old age is because you lose your telomeres. We've been talking this way for so long. Yeah. But now there's this study that says that they were less likely to get cancer if they had shorter telomeres. So it's kind of very counterproductive to our previous understanding about what telomeres do and how they help you.
So we always want to have the longer telomeres, but the longest telomeres, it's probably a Three Bears scenario, right? Where, one's too long, some are too short, but in the middle is just right. It'll keep you aging healthily and also not getting cancer. There's a combination of the two.
And it kind of all makes sense because cancer is all based on like overgrowth of cells. Yeah. And so if too much telomere, you could see it kind of all makes sense in my brain now that you think about it, but it's Goldilocks scenario for sure.
I don't know. I love the idea of being old longer if being old is not quote unquote old. If it's what I mean is it's a better old where you don't feel old because all your cells have been refreshed, your brain works, you're not having those senior moments, you're not aching as much, everything's working. I mean, That's
I
what
could
it's all
send
about.
cold soup back at the deli for the next 100 years and be completely happy. I'm fine with being home.
I've said it once, I'll say it 1,000 times. If my brain works and my mouth works and my ears work and my eyes work, throw me in a jar. I don't care. Throw my head in a jar. I want to live. I want to
What
live
if they
forever.
put you in a
Wait,
robot?
wait a second. How is your mouth going to work? Your ears going to work, guys? You know, if you're a brain in the jar. Have you thought this through, Blair?
No,
Have
not
you
a
really?
brain. The head. The whole head.
Oh, the whole head. Oh.
Haven't thought
Yeah.
it through. Oh my, oh my, oh my. Oh my goodness. I'm going to take a moment right now. I'm going to take another moment because we just finished number 6. You're listening to This Week in Science, and we're here running down the top 11 of 2020. If you want to know more, keep on watching or listening. If you're interested in a TWIS shirt or mug or other item of our merchandise, head over to twist.org and click on the Zazzle link, and you will be able to browse our store and get really, really some pretty cool merchandise. The whole TWIS team for Christmas just got a navy blue TWIS blue-footed booby sweatshirt, and it's pretty great. It is pretty great. Yes, Blair's holding hers up. It's good. It fits well. It's nice. We like it. It's good. But it's time to move on to
Number 5.
Five.
five. What's
The
number
gut-
5?
The gut-brain connection. A little bit of microbiome, a little bit of how the brain works.
Nice.
Yeah, another year of discovering that our stomach and our brain might as well be right next to each other. They seem like they're far away from each other, just both minding their own business. But really, they could be organs right next to each other with the amount that we discover that they have been interacting all this time. This is one of the stories is a bacterial species found more often in feces of older individuals was linked to a loss of cognitive or a cause of cognitive impairment when transferred into healthy mice. So you could actually create cognitive problems just by taking the poo from one mouse and putting it into another. We also found that the microbes influence the development of brains while the young are in utero, according to another study looking at mice.
Yeah, I thought that one was pretty amazing, that there was this connection between the gut microbial community and the developing embryonic brain. Like that, I thought was pretty fascinating.
So, and then I wonder, like, too, you know, how much of this has been nutrition? How much is nutrition based now on what you can absorb thanks to your microbiome? And how much of it is your microbiome actually itself creating things that are separate from the nutrients that are in it? Still a
Right.
fascinating world that we're getting.
Metabolites produced by microbes are a very important pathway. Yep.
And we've known about that for how long?
A long time.
Well, I mean, comparatively, like not that long. I mean, really, we haven't been focused on how influential the gut microbiome is. We've been talking about it now. I would say
a decade.
a decade. Yes. Yeah.
It takes
So-
time for conventional medicine to shift on some of these big topics, right? Where like you under the whole idea of a 2,000 calorie diet and this is good for you and that is bad for you sort of thing. It takes a long time to completely shift that whole ideology to like, hey, before we look at your diet and stuff like that, we should do a panel of your microbiome and analyze that. And then we can tailor a diet specifically to you and what your body needs.
Yeah. And so we've been talking about this 10 years. The research has been coming out for 10 years. There's a delay before there's actual actionable stuff that can be in front of a medical practitioner. I really feel like we're not there yet still. And yet we have and then that amazing story that the gut is able to send immune cells to the brain during relapses of multiple sclerosis to help the body function normally. You know, we're talking about a big part of our immune system is existing within this gut, existing within this community. And there's, countless other stories that we've touched on over the years and over this past year. But it more and more sounds like there are direct connections to human health that aren't aren't tools in the little side satchel of things the doctor can take out and treat patients with yet. And yet we know how crucial they are to human health at the same time. So another one of these things that we talk about that you're sort of getting all the information now as the researchers make these discoveries. And then the next thing is, how soon can we get these implemented into our human health? And how long will it take before we know enough about what we're doing there to make those implementations safe and productive?
Yeah.
Yeah, I mean,
for the prediction show.
Yeah, that'll be good prediction. But yeah, I think that's the big, as we're learning more. I mean, yes, there are still so many outstanding questions, but there's the question of application. Because at this point, from all the microbiome researchers we've talked to, they're like, probiotics, meh, I don't know. Not really the big thing. You could take them. It's fine. They're not going to hurt you. But there isn't that much evidence the probiotics or any particular mix of things helps. And so that is the application is still, we're learning how the systems work, but we haven't learned how to really fix them or work with them or boost them.
On a very barbaric level, we can use probiotics.
That's what I was saying. Yeah, it's like you could take it, but it's just we don't know exactly what's happening. It's fine.
There is a you should take it scenario. I mean, if somebody has been taking antibiotics over a course and has been knocking out a lot of actually maybe the ill effects that people experience from antibiotic use is just knocking out the microbiome as well. So there's scenarios where you can throw the big rock and hope it fells the beast in tackling this problem. We're still at that level of Stone Age technology when it comes to microbiome. However, there's already things that if you have an irritable bowel, there's probably a bacteria in there that you were wanting to knock out and replace with something that won't do that. We've actually seen, this might have been last year, but there was, cases where there was a correlation between people with IBS of bacteria that people without it didn't have. And so they were sort of identified as bad actors somehow within that scenario. Now, whether that's because their natural predator within their microbiome is knocked out or that they were taking advantage of something else going on, those are the questions that we still need to have answered. But
yeah, it's a whole ecosystem in there.
It is an ecosystem. Ecosystems are complicated.
Yeah. You can't just throw king toads in there to eat the locusts. You might end up with a giant invasive toad problem.
And then you have to have the rats that'll eat the guts of the toads and oh my God, all the things.
You can do it. We just know it ends badly.
Yeah.
Let's try and make it end well. We are moving on down our list. We're on number
4.
Number 4 is room temperature superconductivity. This year, just a single story. Superconductivity. We've been talking for decades. And I can say that because this show has been on for a couple of decades. We've been talking for decades about the goal of achieving room temperature superconductivity. Engineers and physicists have been searching for this achievement. And this year, they got there in a sense. So the discovery was achieved under incredible pressures. It wasn't atmospheric pressures, for sure. It was massive pressures, like the bottom of the ocean kind of pressures. We're talking about pressures that we would not be able to survive under these pressures. But laser beams and other forces being used to take a little tiny atom and smash it in a space. And you know how they build these things in in physics labs to try and do extreme experiments. But it was at room temperature, about 50 degrees or so. It wasn't, comfortable, but you could put on a sweater and be comfortable. It's so room temperature. We're not talking about super low kelvins. We're not, which has been historically the case for superconductivity experiments, where it's had to be really cold to slow everything down enough, slow the movement of the molecules, the atoms down enough to be able to get to the point where they could make something superconductive. But this experiment achieved superconductivity within a fairly normal range of temperatures. The next step, now that they've got this there, is to start letting up on the pressure a bit, right? But they have a workable model. And this is the first time in decades that I can remember this. I mean, this is a big achievement. It's huge.
They just got to meet in the middle, put it in a freezer at half an ocean's temperature or pressure or something,
right.
Get it somewhere in the middle. We can find something that'll work.
Maybe they can find something that will work. I mean, this is just, it's not the first because, like I said, this is a process and it's one experiment leading to another experiment, leading to another experiment, making it progressively better and better. But this was an incredible achievement. And in the years to come, I have no doubt that that pressure will get more normalized, and we're going to see some room temperature, almost normal pressure, superconductivity, which would make for some very interesting technology advancement. Okay, should we keep moving up the list?
Let's go.
Number 3.
Three.
What's number 3? Oh, number 3. Artificial intelligence and AlphaFold. This was a latecomer in the year back in November, and AlphaFold is a Google DeepMind endeavor for protein folding. It was reported that this AI was able to reach about 90% accuracy with machine learning and predict the structure of proteins based on basic amino acid sequences during a contest that has been attempted by many groups and many different protein sequencers through the years. This has been huge. Protein folding, knowing how a protein folds from its original amino acid sequence to that final tertiary structure there's so many complexities, so many minor forces involved, pushing away, attraction, lots of stuff happening at these very, very tiny molecular scales. And AlphaFold, for the first time, really, I mean, we've had good advancements with people-powered protein folding, and we've talked about that on the show a lot, but that people-powered pattern recognition may, at this point, not be a match for AlphaFold. What has taken people weeks to months to be able to sequence, AlphaFold was able to do it in days. So based on processing power, based on the algorithm that's being used, based on this, I don't know, it's beyond brute force. It's moving on to something more nuanced. And the interesting thing is because this is artificial intelligence, it's going to be solving things and giving us information that in the future, we won't know how we got it. Be like, how do we know that this protein's going to look like this? Oh, well, the computer told us.
Mm-hmm.
But what do you mean? Like, how does it actually work? We don't really know. The computer tells us. And that's really going to be a lot of biotechnology and protein synthesis and the development of drugs for medical uses, for therapeutic uses moving forward. It's really going to be based on these technologies. And if AI is involved, there's a black box that we don't really have access to, which is really fascinating in my mind.
I'm just thinking about how this is going to revolutionize learning about microbiology.
Yes.
So
It's just going to be such a cool tool, even just outside of general research and stuff like that, about just the way computers have gotten so much better just in general in their use in universities and school. I now picture every microbiology college class, undergrad to graduate level, having access eventually to this AI that can predict protein structures. It's going to be part of your exams. They're going to say like, okay, here's this protein, figure out what it's going to look like. It's very exciting to me to imagine how it's going to revolutionize our knowledge of proteins. It's very cool.
A tremendous amount of time is spent, I've seen by microbiologists working in biotech, coding and coming up with scripts to help do analysis or to dig into all of the genomic information to find the signals, as well as to do the development of trying to figure out what's the best way to even attempt to engineer something or nudge it in a direction of being more efficient or doing a specific catalyst activity or whatever it is. If this technology gets to the point where it can do that predictively, that is an entirely different future than the today looks like. Completely different. There's not a drug, fuel source, textile, cleaning product, food thing you can imagine that can't be affected and improved and utterly changed by this.
Yep.
It's huge.
It's huge. It's huge. I mean, it's like I said, similar to the superconductivity. It's at this stage where there are still advances that are going to be made. It's going to be integrated into processes similarly to the way that CRISPR has been integrated into lab processes and become a tool. And we are going to see AI, maybe AlphaFold, maybe something related to it over the next 5 years. It's going to revolutionize the way we look at everything. Keep an eye on this one, everybody, because it's going to be a big one. Faux show. Maybe in ways that we can't even understand until we see them yet.
Yeah, and it's sort of like, okay, we've always that picture of the benevolent aliens coming down and being like, here's how you cure cancer. You can quadruple your crop yield.
I don't need an alien if I have an AI to be benevolent like that.
You don't need an alien intelligence if you have an artificial one that works just as well. And also it isn't going to hit you with ray guns if you don't do what they say or whatever. Like, yeah.
I like that. That's good.
That side of it looks good. The other side is the artificial intelligence generally can be weaponized. That's that next thing that we haven't.
We're not talking about that right now.
No, but I mean, I think we're gonna have arguments about it, like we have with nuclear power, like we have with a lot of technologies, where we have to say we want this bad. It's this important for society.
They have scales that need to be balanced
to keep it out of the bad category, and that's going to be an important thing. So if you hear negative things about artificial intelligence, understand there's a reason for that over there. If you hear positive things, it's because there's a real need for that over here. What's the next number? Are we at number 2?
This is This Week in Science. I would like to take this moment to thank you for listening, for watching, and for supporting us for so long. We have been around because of you and your support. What we do every week has to do with you. Bringing you up to date, down-to-earth views on science, technology, new discoveries. We can do more of that with more of your help. So please consider, if you are not yet supporting TWIS, heading to twis.org, clicking on the Patreon link, and supporting us and choosing the level of your support. You can support monthly, $10 or more a month, and you will be thanked by name at the end of the show. Or in a yearly fashion, there are annual memberships now, and you can choose that level of support and know that you are a part of bringing sanity that the world needs, science, which definitely we need more of, because that's more hope to more people. Thank you for your support. We really can't do it without you. And now we're coming back to number 2.
Oh, I'm sorry. I was just looking at my calendar here that's still available for sale online. Number 2, we have to talk about it. We talked about it literally, I think, every single week in 2020, even before it got crazy. We're going to talk about COVID, but just for this one item. Now, we could talk about all sorts of things like how we didn't know what it was at first, how we didn't know where it came from at first, how we didn't know how communicable it was at first, how some people were saying maybe it's not so bad, maybe it's just kind of a worse flu, and then things got out of control, and it was all of that. But really, what we wanted to focus on as number 2 is the amazing research effort that went into everything. It was such a good, organized effort, and everything happened, I'm going to say quickly, but quickly in the right way. Because also, that's all a whole extra bag of beans. I don't know what the phrase is, but really, the research happened so fast for us to be able to identify how to stop the spread, whether we did it or not, but how to stop the spread, what the best moves forward were, and most importantly, we have the first ever approved and being used mRNA vaccine. We have 2 of them.
Not one, but 2. Yes.
And we have more vaccines that are going to work completely differently and also in new and exciting ways on the precipice right now. That's going to come out in 2021. But, the mRNA vaccine, it was something that we kind of teased towards the beginning of the year. You're like, oh, is this going to be it sounds like it could work in theory, and it's using CRISPR, right? So like that's tying back into what we were talking about before. But it's inoculating people in a way that we've never done before. So I don't know. It's astounding to me. It's exciting. I think it's amazing how transparency was there to help guide us through the process. So it wasn't just like, boom, there's a vaccine. Do you want to take it? Some interpretation maybe was needed because there hasn't been that level of transparency for vaccines in the past. And so I think there needed to be some explanation, which is partly what we tried to do, hopefully. But the transparency, I think, and the cooperation across countries also was really inspiring. And it's set up to be pretty life-changing. So
one of the fun backstories too is there was a woman who was at Penn State who had developed some of this mRNA technology published on it back in 2012. She wasn't producing enough work for the satisfaction of the university. She got knocked off her tenure program to be professor. She struggled to get funding. They bypassed that funding to give to other people. And she persisted. She got knocked off a tenure track and stayed at the university to pursue her work, eventually creating that technology, which they have patented, and left to join a biotech company, or run the biotech company, the research department of a biotech company, which is now partnered with Pfizer, which is how they have developed this. So this is sort of, it's not quick. It looks that way to the outside observer. Hey, scientists were like, hey, here's just a new problem. Knocked it out of the park.
Yeah,
right.
Yeah.
This is people who've been working really hard, and sometimes
for decades.
And sometimes
it's on the shoulders of giants and masses of previous publications.
Yeah, and so this is a lot of hard work by science. This is why we need to fund these people. This technology that came out, or this paper that was published 8 years ago, could have been much more advanced by now if we had seen the value in it sooner, or if the grantors had seen the value. So there's a lot of these backstories that I can't wait to hear. I can't wait to see that really good deep dive into the people behind these different vaccines that are out, the research that went into it, and how it got there.
And I have to tell you on a personal note, I know Beth just shared in the chat room that she's so grateful to have received her first vaccine on Saturday. But I think probably everyone listening at this point knows that my husband works in the emergency room. This has been a long 8 months, and I've tried to be very effusive and supportive and not kind of try to show how intense and scary it was at times. Yeah. And he got his first dose almost 2 weeks ago now. And I'm like tearing up now because like it's a huge relief to feel like he is protected. Huge relief.
And if not 100%, at least partially. Even
absolutely.
Just a little bit is going to help. And that's amazing.
Yeah, because he's going out there every night and he's working in the ER and taking care of people that some of them have COVID, some of them broke their leg and might also be an asymptomatic carrier. And every person he comes in contact with every night could potentially get him sick. Yeah. Just the number of contacts that he has, no matter how careful they are, it's huge to me that this was able to happen as quickly as it did and as safe as it did. And I was so proud of him that he went for it right away, no hesitation. And I was so excited that he got it.
Brian's a stud. Absolutely.
I mean, not just Brian, but so many of our frontline workers. I know nurses, doctors, firefighters, so many individuals who are stepping up and getting the vaccines and not shying away from it, and it's going to help. It's going to protect not just them, but hopefully other people, because they won't be as able to carry the virus. And so. Right. You know, the hope is that this is really going to turn the tide on the entire pandemic. And I mean, we're still in for a couple of months of, I mean, we're moving into 2021 and we're all excited to be done with 2020. And I'm just going to cap it off with we're finishing up a really bad year. The next couple of months are still not going to be easy. Our ICUs are full. Our hospitals are pushing people away. Ambulances are leaving people at their houses. Like, things are bad at the moment, and we have New Year's Eve happening right now. Mm-hmm. We just had Christmas. It's going to get worse because there are a lot of people still not being careful.
Yes, absolutely.
But if people, so we're in for a couple of months of really bad still with hospitals and our infrastructure and things being pushed. So please continue to be careful to protect the healthcare workers that are not vaccinated, to keep yourself and your loved ones out of the hospitals so that you're not putting any additional pressure on that infrastructure. Please do the best that you can. It's going to be a little while longer, but there is a light at the end of the tunnel because of the vaccines. Regardless of, I mean, we also have amazing research going on, the ability to genetically sequence test samples. If this had happened a decade ago, we would not be able to do this as rapidly. The fact that we have isolated a new variant of the virus in the UK, another one in South Africa, we know it's all over the place. It basically, if countries or localities are testing, they're going to be finding these things, because if you allow viruses to replicate, they will be mutating, and that just is part of the whole process. The more you let it spread, the more mutations happen, the more possibility for escape from vaccine. So please be careful so that we can maintain the usefulness of the vaccines that we have, so that we don't have to, the research companies and the pharmaceutical companies don't have to go back and tweak their formula anymore. They can, and they will, and it'll happen, but we have the power to slow it all down. And I think that is, as tired as we are, stay home, have a Zoom New Year's, and be careful so that we can have a great 2021 after everyone's vaccinated. Please. The researchers have been working their butts off this year so that next year and the years following will be better. I have to say, I got a soapbox here, didn't I?
Yeah. No, that's good. It's important when we talk about it. It's something I've noticed also. This is a whole extra tangent. I'll be quick, but the show has really, I feel like, has grown with the times in a way where, towards the beginning, it was just like very black and white science reporting, right? To a certain extent. And then as kind of social media grew and the media itself kind of grew and the interpretation of science got kind of more mucked. I feel like that's also when we started to recognize that science is kind of forced to be somewhat political and social and opinionated. It has to be part of the conversation, and I think that I have really appreciated this show for that as kind of an outlet to be able to have those conversations and discuss the kind of the data influenced but not data based part of the conversation, which is exactly what this is, right? Is like, what is the social implication of the data that we have this week? And COVID has been a time where one of the stories we talked about on the show this year was about how COVID was a moment where we really saw how conspiracy theories are birthed and grow and garner support in our current era. And so this has been a really good opportunity for us to help try to squash those as well. So yeah, hopefully that happened a little bit here.
Yeah, I hope so too. And I think that pushes forward to number one. I think this really is a good place to transition to our number one story.
Number one.
Number one.
Oh, 2020.
Which is Me Too STEM and Black in STEM, and really underrepresented people in STEM. And the voices that were amplified this year, the people that were given platforms that had previously had none or very little, gave us insight into what science has been lacking, gave us insight into what science could be and how much better the institution of science can be if we allow all people to stand equally so that certain voices are not diminished. And so this year, because of, we first saw Me Too STEM arise, and then we saw the riots, and out of the riots came Black in STEM, Black in Ivory, Black in academia. And there were days of protest where Black academics stayed out of the labs, stayed off the university campuses to show what was missing. And that was a very important point that needed to be made. And for the rest of the year, we saw special weeks in social media. There was Black in microbiology, Black in space, Black in chemistry, Black in psychom, Black in, you name it, Black in birding. They're Black Birders Week. I mean, every section of scientific inquiry needs to have diverse voices. And if diverse voices are left out, we are going to be missing pieces of the puzzle. Are we really curious about the world? Are we really curious about the universe? We can't just let certain people tell the narrative.
Well, and there was science this year that came out that showed us that even if you have a double-blind study with a large sample size and all these other things, if all of the researchers are white men, your data is different. So one of my favorite ones was that historically research on bird calls have only looked at male birds because the assumption was that only male birds sing, which is just silly. And so then they discovered, a female researcher was like, maybe we should look at female bird song. And so it's just
maybe.
Just like duh.
Yeah, look for the things, ask the questions, allow the stories to be told. There is room for improvement. And so the reason it is the number one topic for 2020 is because of the ultimate impact that changes that started this year could have and hopefully will have on science as a whole.
It's a question of not just making sure your door is open, but making sure that everyone knows that door exists and can get to that door at all. Really, it's like a square one conversation.
Yep. What door? What do you mean there's a door? Yeah.
That door's not for me. Oh, yes, it is.
I'm sure everyone has had an experience where you learn about something for the first time, and it's just mind-blowing that this thing has existed in the world unbeknownst to you for decades, centuries even. You had no clue. And there are all these people who are part of a community who are like, oh yeah, I totally talk about this all the time. I have dreams and talk in my sleep about this. You're a newcomer, and it's like, how come I never learned about that? It's all a part of access. If you've ever had that experience of realizing you haven't had access to something, you understand what a lot of people experience every single day. And it needs to change. So,
And then once you get access, the institution cannot be hardwired against you, spring-loaded against you. Something in this documentary that I think we all watched from AAAS. I won't go into details about it, but it was a couple of female future scientists starting their post-grad work, looking around and seeing 60% of the class, their classmates were women. And we're like, this is great. Women in STEM, it's happened, it's here. By the time they graduated, that number had been dwindled down to less than a quarter of the class. Yeah. Something between entering and exiting that institution had a filtering effect on them, on the population of who got through. So, you need the access to get in the door, but you need that institution also to be functioning without the next level of stuff. But it's maybe even the first one, because that's how you get the influencers, that's how you get the teachers, that's how you get the role models in society, that's how you get the people who are going to actually be in those labs and breaking those as well. So.
Yeah. If you change the institutions, which is, I believe, the conversations and hopefully the practices to change have started in many places. If that process continues, the institutions hopefully will change enough so that those, like you said, the influencers will be there to grow awareness, to drive interest. And that will, I don't know, but it's going to have such a huge impact. So that's number one. I don't know what your top 11 for 2020 would have been, all of you out there. But let us know if you agree with our countdown or not. Let us know. You can leave us a message on our Facebook page, over on Twitter at TWIS Science, or you can send us an email. Let us know. But okay, we have finished our official top 11 countdown. Now, let's talk about
the weirdos.
The weirdos. Honorable mentions and weirdos. Yes, let's get there.
Yeah, just kind of a cursory glance. First of all, I have to mention what I said was, I think, my favorite story of 2020 when I reported it, which is about pandas rolling around in horse poop to give them the feeling that they're warmer in cold, even though it doesn't actually make them warmer. It's just there's a chemical in the poop that's like, it's almost like menthol in a Vicks Vapo Rub situation. So they think that they're warmer for a second. So they roll around in horse poop. So there's that.
Poop. I'm warm, but I'm not.
Hey. You're both mocking it, but have you tried it?
No.
Have you tried rolling around in horse poop on a cold day?
I will tell you, Justin, remember, I was a zookeeper. So I have had many types of animal poop on my body. I will
not rolled in. You have not rolled in it.
I've fallen in it.
Oh, okay. All right then.
But was it cold at San Francisco?
Honestly, yeah, I don't know. Anyway, so next, just a quick mention of frogs and toads and the amazing gifts that they gave us this year in a story about snakes disemboweling frogs and eating their organs while they're still alive. And then, of course, a story about toads and live beetles escaping from their vent. Yes, you know what that is. Again, while they're alive, live beetles coming out of their rear. Yes. So that
they're bottoms.
Also, now I'm thinking maybe I confused the frogs and the toads. Did I?
Did you?
The other frog. It doesn't. Nobody
I don't
can tell the
remember.
difference.
Frogs. I can tell the difference. I'm just frogs. So yes, so the frogs are the beetles and the toads are the snakes. See, I didn't write it down, and I got it.
So the snakes disembowel the toads,
right?
And which is good. That's a good thing,
Is that
right?
cane toads? Is that what's or poisonous toad?
This is the Asian black spotted toad. So I don't remember now. Is it good? I don't think it's good. So they this is a poisonous toad, and that's how they get around their poison gland.
Yes, that's right. They disemboweled them so they wouldn't eat the poison. Yes.
Yeah, I don't think this is actually a good thing, but I think it's just how they eat them. But yeah, so next time a small child asks you what the difference between frogs and toads is, you can say, you see, toads get disemboweled by snakes, and frogs have live beetles crawl out of their rears. So there you go. Yep. You're welcome. Okay.
Okay.
Also, there was a lovely story about alligator corpses in
this was one of my favorite stories.
Yes, tell me about it, Kiki. Do you remember?
Yeah. Yes. So this story was researchers wanting to know more about what goes on at the bottom of the deep ocean. So they dropped dead alligators down to the bottom of the ocean and then just watched to see what happened. And they found they let them decompose, they let animals eat them, and they discovered a new species of bone-eating worm as a result of doing this. And also there was something that came along and was big and took huge bites out of these alligator corpses, and they don't know what it was, but it was something giant at the bottom of the ocean that ate the corpses.
How big are we talking?
Big. Big enough to really eat an alligator.
Eat enough to big an alligator. That's right.
So what's with this? How is bone worms just always hanging out at the bottom of the ocean, waiting to start a life cycle?
Yeah, so there are all these invertebrates, these worms, and other things that are just waiting for the falls, right? They're down there and they conserve their energy and they don't do a lot until something edible comes around, and then everything. It's like an oasis, and they're like, yeah. Chew it all up. Crustaceans, all sorts of stuff. But they found pillbug isopods chewing on these alligators. But there was a lot of stuff going on down there. One of the corpses that they retrieved was just a large predator had eaten it and hauled the carcass away. They think maybe a shark, but they don't know.
Sure.
Anyway, I just thought that was just such a fun story. I'm like, oh, what goes on at the bottom of the ocean? Let's throw dead alligators down and see. Like,
I mean, why not?
Talk about observational science.
Speaking of the fishes, four-eyed fishes of the genus Anableps have left-leaning or right-leaning genitalia. They assumed that was a genetic trait, but it turned out to just be luck.
I thought that was a really funny story, Blair. I remember when you reported on that one, and I was like, really? We're talking about fish genitalia? And
we sure are.
Left or right leaning by chance.
It's random, indeed. And speaking of genitalia, as you do in Blair's Animal Corner, sperm. We learned this year. I love this. This is a life changer for me. Sperm. We don't look at it in 3D very often. Turns out they're corkscrews that spin. They don't swim.
They don't
like this.
They don't have like their side to side or the up and down wiggle.
They're drilling.
They're drilling through, which explains why some sperm are way faster than others. Is because just like I think about like opening a bottle of wine. I don't know if it's the right time. And like sometimes you can just like pop, right? But like sometimes you're like, can't get through that cork right, or this corkscrew's bad, or whatever. Anyway, so they drill. So I love that.
Drilling sperm.
Also, eye spots on the butts of cows. has them predated less often, so they look. It's like eye spots on a butterfly that look like an owl eye. It's this is actually happening. I think it's in Africa, right?
Yeah, they painted eye spots on the butts of the cows.
Yeah, so they actually
lions are looking to attack from behind. They don't want to attack for head on. So yeah, they're like, this one has a head on both ends. I don't know what to do.
It's in Botswana. Yeah, so not only is it on both sides, but those are that's binocular vision, which looks like a predator, and the eyes are way bigger than cow eyes. So it looks like, especially in the dark, it looks they specifically tried to draw lion eyes. So it looks like another lion. So like, no thanks. Humans might be able to sense magnetic fields.
Maybe.
Right. Yes, that was this year. That was they isolated people in a little like a box that had no vibrations and had like it was isolated, this soundproof, vibration-proof box, and then they changed magnetic fields on them, and people were able to sense it.
Yeah, it's
better
I
than
need a bigger sample size, I gotta say, but it's interesting.
Yeah, it was a proof of concept, but as a concept, it's like what?
Yes, and then also next to last in weird technology, everyone knows what I'm saving for last in the show, but your smartphone could tell when you're drunk based on the way that you move around.
Right. So, stick that phone in your pocket and it's the sway in your hips.
The way that you move could tip off your phone as to whether you're drunk or not. And last but certainly not least,
I'm ready.
A new toilet design identifies users, you guessed it, by their anal print. So just like a thumbprint, they can take a quick peek, identify you, and assess your health.
Wait.
You don't remember this story, Justin?
Wait a second.
So first,
so it's taking a picture.
I mean, yes and no. It's like, it's
like a fingerprint can identify the human.
Yes.
I'm gonna go ahead and say like, oh, that's Greg. Let's see how Greg's urine is today. Oh, you need to drink more water, Greg. If Greg sits to pee is the thing.
Or if somebody is a diabetic and you're sensing sugar levels in the urine, or if somebody has hormonal differences that need to be monitored, or if you're monitoring medication and how it is coming out of somebody.
Or if there's blood in your stool.
Or if
there's
an
important thing to
all
know.
sorts of things to track. And this toilet could identify it by the person and tell the doctor.
Or you could just put in a number. Is that what you're going to say?
Or if you just want that next level security system.
Oh, yeah. Yes.
Nobody else.
Unknown rear detected. Somebody broke into your house.
Somebody broke
how do I get into this top secret compartment? Is it like a retinal scan? Nah, those can be copied now. Is it fingerprint? Oh, that's too easy. No, we have another.
I gotta tell you though, why not just be like, I'm number 2 on the toilet?
Like a seat setting. Like a comfortable seat setting you would have. You just hit the button and it kind of gets the angle you like anyway. How come toilets are not adjustable? How come there's no height adjustment on a toilet though?
Just say your name. Like that technology definitely exists. Why?
What? Yeah. Why do you have to have the printing?
Yes.
Why does it have to identify you by your rear end?
Because somebody wanted to prove that it was possible.
No,
and you might not understand the significance of this at this moment. But one day, that technology might be the thing that saves humanity.
Right? It's the bio
Have you ever heard about
right?
this in forensics? Have you ever heard about this, like, from any forensic? Dun, dun, dun. Okay, we're going to solve a crime, and we're going to go to the lab for part of the show and do some sciencey talk about a cadaver. Have you ever been like, well, we couldn't get fingerprints or dental records.
But his derriere was intact. Yes.
But we still managed to identify how you had only all you had. You didn't even have a torso. Yeah, I apparently didn't need it. You didn't even have legs with it. No. You only had a small portion of the victim. Yeah, but it's fine.
Yeah, it's fine. It's fine. We got it.
Now, you're right, John. We need to put this story behind us. Go on to the next segment.
But that is the end of our.
Was that the end of the year as well? That seems suiting.
End.
This brings us to the end of our show. Say for me.
Let's put 2020 behind us.
Yes. Let's look forward, putting our best feet forward. Yes. Imagining what science will come in the year to come, 2021. It's been a great year for as much of a terrible year. For as terrible of a year as it's been a great year. There have been some good moments. There have been some great achievements. The science has been amazing. And I am so glad to have gone through it with you. Thank you.
Yeah, I mean, we were the original Zoom hangout, I gotta say.
People are like, how do you do this? And I'm like, it's pretty easy. We got this covered. Just watch our show. It's fine.
Yeah. It's definitely. It's one thing that didn't have to move virtual. It just already was virtual. This one thing didn't change in my life and felt static and solid and kept me grounded in such an amazing way. Otherwise, we've all seen the tweets and things about people not knowing what day it is, but at least on Wednesdays, I knew what day it was.
We knew when it was Wednesday. Thank you. Yeah. Thanks for all of this. We've come to the end of our show. It is the end of another year. Wow. We've been waiting for this. Happy New Year, everybody. Thank you for joining us for another episode. And I do hope you enjoyed it. I hope you enjoyed our review of the year. I want to give some shout outs to Fada. Thank you for help with social media and show notes. You put so much effort into the work that you do. Gord, thank you for the chat room. Thank you so much for that. Identity 4, thank you for recording the show. You have made this show possible in so many ways by recording it. And for the Burroughs Welcome Fund and our Patreon sponsors, thank you for your support. We really, really, really can't do this without you. Thank you to Woody MS, Andre Bassett, Chris Wozniak, Dave Bunn, Vegard Shefstad, Hal Snyder, Donathan Stiles, a.k.a. Don Stylo, John Scioli, Guillaume, John Lee, Ali Coffin, Gaurav Sharma, Shu Bruce, Sarah Forfar, Darwin Hannon, Donald Mundus, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Fred S104, Skyluke, Paul Ronovich, Bentley the Translator, Big Nell, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Joshua Fury, Shauna Nina Lamb, John McKee, Greg Riley, Mark Hessen Flo, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rappin, Richard, Brendan Minish, Melazon, Johnny Gridley, Kevin Railsback, Flying Out, Richard Porter, Christopher Dreyer, Mark Massaros, Artyom, Greg Briggs, John Atwood, Conrad Michaels is a Russian super spy, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul, Matt Sutter, Philip Shane, Kurt Larson, Mountain Sloth, Jim Drapeau, Sarah Chavez, Alex Wilson, John Ratnaswamy, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Stanton, Paul Disney, Patrick Pecoraro, Ben Rothig, Gary S., Tony Steele, Ulysses Adkins, Brian Condren, Jason Roberts, and Dave Friedel. Thank you for all of your support on Patreon. And if any of you out there are interested in supporting us on Patreon, head over to TWIS.org and click that Patreon link. On next week's show, it's our annual prediction show.
We're going to be telling you about the future.
Yeah, we predict the future. We'll review our predictions from last year, which I haven't looked at them yet. I've been holding off on it, and I'm really interested to see how much of 2020 we actually got right. But
I can think of a couple things we did not get right.
Yeah.
I can think of one big thing we missed.
Yeah, totally. Totally. But we'll be predicting 2021, and hopefully this next prediction round we'll have some more winners in it.
And when are we going to do that? Next Wednesday, 8 p.m. Pacific time, 5 a.m. Central European time, broadcasting live from our YouTube, Twitch, Facebook channels, and from twis.org/live.
Hey, do you want to listen to us as a podcast? Maybe
Sure.
while you bake some bread or cookies or clean the house, just something fun you can do while you listen. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, please get your friends to subscribe as well.
For more information on anything you've heard here today, show notes, links to stories, and other available information on our website, www.twis.org, so you can sign up for our newsletter.
You can also contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or me, Blair, at blairbaz@twis.org. Just be sure to put TWIS, TWIS, in that subject line, or your email will get spam filtered into last year.
Oh, which is this year? Which
is this year, which is, you don't want it going there.
No.
Hey, if you don't think that you get any questions answered here, want to talk to us more, see what we're talking about, you can hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week for that prediction show that Kiki mentioned, and we hope you'll join us again for more great science news.
And if you've learned anything from this last year of This Week in Science, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world, so I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice, show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand, and all it'll cost you is a couple of grand. 'Cause this week's science is coming your way, so everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And This Week in Science is coming your way, so everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science. This Week Week in Science. This Week in Science. This Week in Science.